Do you know that there was not enough understanding of how to calculate the rate an ice cream melt, a balloon is being inflated, or how fast the champagne is increasing? Or basically, have you ever wondered how mathematicians have came up with calculations for everyday life use? Guess what? The application of derivatives was developed to improve this understanding. The two main applications that we will be looking at are using derivatives to find solutions and how to find related rates and optimization. But first, what is related rate? What is optimization? Related rate problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known, while optimization problems involve finding for the largest value for the smallest value that a function can take. I know these definitions are quite confusing to you, so let me just show you some specific examples.
Let's begin with the first problem about related rates. Take for example, a boy named Mark observed a pile of sand form into a shape of a cone. Mark assumed that the sand is being poured at 2 cubic meters per second. He also assumed that the height and diameter of the base is equal to 8 meters. Now, he wants to know how fast the height of the pile is increasing with a given measurement of the base. In order to fully understand what the problem is all about, we need to draw a free body diagram. The height of a pile of sand is equal to the diameter of the base, which is 8 meters. The derivative of volume with respect to time is equal to 2 cubic meters per second. Let's begin with using the formula in getting the volume of the cone, which is 1 over 3 pi r squared times height. However, we cannot directly use this formula considering that there are two variables involved. Since variable h is needed to determine how fast the height of the pile is increasing, we should write r in terms of h. But since the base is measured in diameter that is equal to 8 meters, then the radius is 4 meters. r in terms of h is now equal to 4 over 8. We need to cross multiply, making it 8r is equal to 4h. Isolate r by dividing 8 in both sides. We now arrive with r is equal to 4 over 8 times height, making it r is equal to 1 over 2 times height. Let's go back to the formula of getting the volume of the cone. V is equal to 1 over 3 pi r squared times height. Replace r to 1 over 2 h. 1 half h raised to 2 is equal to 1 over 4h squared. We can have the formula V is equal to 1 over 3 pi times 1 over 4h squared times height, or equal to V is equal to 1 over 12 pi h cubed. Let us differentiate both sides of the equation with respect to time. The derivative of volume is derivative of volume with respect to time, while the derivative of 1 over 12 pi h cubed by constant multiple rule is 1 over 4 pi h squared times the derivative of height with respect to time. Let us isolate the derivative of height with respect to time by dividing both sides by 1 over 4 pi h squared. Simplifying, we can have an equation of the derivative of height with respect to time is equal to the derivative of volume with respect to time divided by 1 over 4 pi h squared. Plug in the value of the derivative of volume with respect to time, which is equal to 2 cubic meters per second, as well as the height of the sand equal to 8 meters. Simplify the denominator to get 64 over 4 pi. Divide 64 by 4 to get 16 pi. Finally, we can have an answer of 1 over 8 pi meters per second. This is how fast the height of the pile is increasing.
Let's move on to the next example. Grant wanted to mail a cylindrical package through parcel post. However, the postal regulations in the city state that packages must have a length plus width of no more than 84 inches. Because of this, he wants to know the dimensions of his package of greatest volume that mailable by parcel post. In order to find the dimensions of the cylindrical package, we need to list down the given in the problem. Remember that the length plus width is equals to 84 inches. Since we cannot directly use this equation, we need to draw a free body diagram. From here, we can find the length and width of the package. Now in order to find the width of the package, we need to take into account that the base of a cylinder is a circle. From this, we can safely assume that the width of a cylinder is equal to the circumference of a circle, which is 2 pi r. We can also assume that the length of the cylinder is also equal to its height. Now we can rewrite the equation as length plus width is equals to 84, as 84 is equals to height plus 2 pi r. We then isolate h, which will then give us the equation h is equals to 84 minus 2 pi r. This will help us in our next calculations. Remember that in a cylinder, the volume is equals to pi r squared times height. However, we cannot directly use this equation since there are 3 variables involved. What we need to do is write h in terms of r, which will give us the equation volume is equals to pi r squared multiplied to 84 minus 2 pi r. Now we can solve for the radius, which will then allow us to solve for the height. So first, we need to distribute pi r squared to 84 minus 2 pi r. This will give us volume is equals to 84 pi r squared minus 2 pi squared r cubed. After that, we derive this equation, giving us volume is equals to 168 pi r minus 6 pi squared r squared. Next, we equate it to 0 and factor the equation. The equation will now be 0 is equals to 6 pi r multiplied to 28 minus pi r. The next step is to divide both sides by 6 pi r. After that, we isolate r by adding pi r on both sides, giving us the equation pi r is equals to 28. Now we can get the value of r by dividing both sides by pi. From this, the radius will be 28 over pi inches. Now that we have the value of r, we can now solve for the height of the cylinder by substituting r in the equation, giving us height of 84 minus 2 pi multiplied to 28 over pi. The constant pi will be cancelled out, leaving us with height is equals to 84 minus 2 multiplied to 28. We now simplify the equation, which leaves us with h is equals to 28 inches. To check whether our answer is correct, we simply substitute the values in the equations. To solve for the width, we substitute r with 28 over pi, which gives us 56 inches. To solve for the length or height, we simply substitute the variable w. The equation length plus width is equals to 84, which will then give us length is equals to 28 inches. Substituting these values to the original equation, we'll have 28 plus 56 is equals to 84, which gives us 84 is equals to 84, making our calculations correct.
Now that we have already solved problems about related rates and optimization, I hope that this tutorial has deepened your knowledge in basic calculus and helped you understand about these topics. I wish you all the best and good luck in your future problem solving.